Okay, so today we're going to get into Coulomb's law and ionic bonding. So if you remember from what we've been doing, this is Coulomb's law where the energy is proportional to the two charges and the distance between the two charges. So when we're talking about ionic bonding, we have a cation, which is your positive ion, and your anion, which is your negative ion. So what we can do is, based on Coulomb's law, we can figure out how strong an ionic bond is based on what the two charges of the cation and anion are, and also the distance between them. So what are some things that would affect how strong an ionic bond is? Well, it could be something like the distance between the two nuclei. So for instance, if we have a large atom, so if we have this ion that's positive, and we have an anion that's negative, if they both have 3 energy levels, there's going to be quite a distance between, even when they do come together to form a bond, there's going to be quite a distance between the two nuclei, versus something that might be like, if this is the cation and this is the anion, now, since there's not all these energy levels around, they can actually come together, and our distance between the two charges is going to be much smaller, and therefore going to give us a greater energy, going to give us a greater force of attraction, and therefore make the bond stronger. So one thing you need to look at is what period are the elements on the periodic table to see how many energy levels they have. Then another one, if I have something that's, let's say, if we have an, let's just say it's element X, whatever, is +2, element Z is -2, okay? Since it's +2 and -2, those would be the charges here. That would have a stronger bond than if it was X +2 and Z -1, okay? Because again, then the magnitude of our charges is going to be the determining factor, again, if they're similar in size. But the magnitude in charges is going to depend, or going to give us a good measure of how strong the bond strength is, okay? If it was, let's say it was X +3 and Z -3 versus X +1, Z -1, okay? Again, the +3 -3 is a greater charge than the +1 -1, so therefore the +3 -3 would have a stronger bond strength than, or a stronger bond than the +1 -1. One way that we can actually do this or measure this is with something called lattice energy. So most ionic substances form crystals, and it's called a crystal lattice. Well, lattice energy is what we call, or is defined as, the energy that's required to separate the crystals into a gas. And so what we use that a lot of times to determine the strength of an ionic substance. So if it has a high lattice energy, that means it's really hard to pull apart. That signifies that it's going to be a stronger bond. So if I say compare the lattice energy in, let's say, Ki versus RBI. So potassium iodide versus rubidium iodide, okay? Well, what's the difference between these? So iodine, those are the same. The iodide ion's the same. What's the difference between potassium and rubidium? They're both +1. So the charge isn't going to have an effect. Well, let's look at the distance between them. Well, if you look at potassium is on the 4th period, so it has 4 energy levels. And actually, when we turn it into an ion, we remove that extra electron, so that actually removes that 4th energy level, gives it 3 energy levels. Okay. Rubidium originally is in the 5th period, so it has 5 energy levels. And when we remove its valence electron, it's going to remove that 5th energy level and give it 4 energy levels. So rubidium has 4 energy levels, so this is going to have a greater distance between nuclei. This one will have a lesser distance between nuclei. So if this one's lesser distance, this one's greater distance, this one should have is going to be a stronger bond, because if you think about Coulomb's law, the shorter the distance, the shorter the length between the two charges, the greater the energy. So this one will have greater lattice energy, and this one will have a lower lattice energy. And an explanation is exactly what I did here, right? 3 energy levels versus 4 energy levels, lesser distance between the nuclei, greater distance between the nuclei, greater lattice energy because of the stronger attraction. Okay? So, hopefully this helps. Let me know if you have any questions.